Okay, I'm going to do a couple of these videos kind of shorter, just because some of you will not need to review this whole thing. So when you have uh, radical equations, one of the most important things you have to do is check for extraneous solutions when you're done. And remember, to cancel a radical, you square it, and those cancel each other. So that's what we're going to start off doing. I probably won't finish number one, but we're going to focus on number three and maybe number two. So right away, first thing to cancel radicals is to square them. And then the radical sign cancels. And then that leaves you with 3x subtract 11 is equal to 17 subtract x. And then notice negative 1x is smaller than 3x. So you'd add 1x to both sides, which means you'd then have to cancel that negative 11 by adding 11 to both sides. All right, we're going to come over here. So for number two, notice there's not a radical, but because we have to square this side, we also have to square this side. So the radical and the x squared cancel, leaving negative 27 plus 12r is equal to positive r squared. And then because this is a quadratic, this side will need to equal 0 because we want to leave. You always want the x squared term to be positive when possible. All right, so we will subtract 12r and we will add 27 to both sides. When we do that, those zero out and we have now 0 on the left. And now we've got this quadratic that should factor. So we're going to take factors of 27 that add up to negative 12. Well, if this is negative, if the third term is positive, but the second term is negative, then both of these factors will be negative. Well, negative 9 times negative 3 multiply to be positive 27, but those two add to be negative 27. So we're going to do r subtract 3, r subtract 9, and then the solving part, we look inside each parentheses, and whatever causes a negative 3 to zero out, well, a positive 3. Whatever zeros out a negative 9, that would be 9. But then you have to go up there and check both sides. So let's do the calculator checks over here. So if I chose positive 3, so it's in, don't put the radical sign in your calculator, just do 20, in your calculator, do negative 27 plus 12 times 3, so that's negative 27 plus 36, so that's the square root of 9. And then over on this side, this says r squared, 3 squared. The square root of 9 is equal to 3, and over, never mind. Sorry, this side would then just equal r, so we're good. The square root of 9 does equal 3. So 3 is a solution, and now we're going to do 9. So negative 27 plus 12 times 9 is equal to 9. 12 times 9 is, let's see, 108. Subtract 27, you get 81. Well, the square root of 81 is 9. So both of those answers check out. And now they're in the correct order, least to greatest. Remember, when you come up with your roots, identify those are two real rational roots because there's not a radical, and they're not imaginary because there's not an I attached. And then if you were to graph this at 3 and at 9, those are the roots. Then you'd have a parabola that looks something like that. Okay. Notice when we square both sides, you have to put a parentheses, and now you have a p plus 4 times a p plus 4, and you either FOIL it, or what I say is do the double distributive, because distributive you can use that in every situation. The FOIL, you can only use it with binomials. So I'm going to start the distributive. P times p is p squared. P times 4 is 4p. And then we've taken care of the p now. So now this is the double distributive. 4 times p is another 4p. Those can be added together. And then 4 times 4 is 16. So now we have p squared plus 8p plus 16 is equal to 3p plus 52. But because this is a quadratic, and it's a positive quadratic, we need the right side to be 0. So we're going to subtract 3p, and we're going to subtract 52. So that simplifies to p squared plus 5p. Should have had my calculator handy for this. 16 subtract 52 is negative 36, I think. So let me double check. 16 subtract 52, yeah, negative 36. Okay, so now we've got a quadratic. We're going to take factors of negative 36 that add up to positive 5. Well, think about it. You'd have, if this is positive, we want the larger factor. So 12 negative 3, 18 negative 2, 9 negative 4. Those add up to positive 5. So p plus 9, p subtract 4. And if you put p subtract 4, p plus 9, that order doesn't matter. And now we're going to take the opposite value, because that's what will zero it out. So p is equal to negative 9. And the opposite of negative 4 is 4. But now we have to check. So the original equation on the left side is p plus 4. So put in negative 9. Negative 9 plus 4 is negative 5. On the right side, 3 times negative 9, which is negative 27, plus 52. That's square root 25. So in this case, because there's not a negative sign in front of there, in this case, I believe negative 5 is not, this is negative 9 does not work. Because when we put a negative 9 on the left side, we got a negative 5. The square root of 25, I realize when we're doing quadratics, you can take positive and negative, but in a situation like this, in order for us to take the negative root in the middle of an equation, there would have to be a negative sign out front. So that tells us negative 9 does not work. So now let's try 4. So 4 plus 4 is 8. And over here, 3 times 4 is 12 plus 52. 12 plus 52, square root of 64. So 4 works. So p is equal to 4. And then you'd say where p can't equal negative 9. All right. I think we're going to call that good for this video.